Hello everyone, as you all know me, this is Pavitra L, pursuing BE in Computer Science and Engineering at Sri Venkateswara College of Engineering, Bangalore. Today, I am here to present on a topic milling machines. In today's session, we are going to discuss the definition, parts, working principle, operations, types, advantages and disadvantages, and applications of milling machines. Now, we'll see the definition of milling machines. The process of removing material from a workpiece by advancing a rotary cutter's cutter into it is called milling. The process is carried out by adjusting pressure, speed of cutter head, and direction of feed. A milling machine is a piece of equipment that removes a layer of material from the surface by using a multi-point cutting tool. With the aid of numerous cutting edges, the milling cutter revolves at high speeds while rapidly removing metal. We'll discuss parts of milling machine. First one, base. It supports every component of the machine and can dampen vibrations imparted by milling operations. Some machines have hollow bases that act as cutting fluid reservoirs. The base is generally constructed out of cast iron from rigidity. The second one, column. The major supporting part positioned vertically on the base is the column. It is box-shaped. It contains the table feed drive mechanism and spindle. A dovetail guideway is provided at the front of its vertical face to support the knee. And the third one, knee. The knee gray iron casting slides along vertical guideways to modify the gap between the cutter and the workpiece on the table. This vertical motion is done by utilizing elevating screw provided below the knee. Spindle. It is situated in the upper part of the column and receives power from the motor through belts, gears and clutches and transmits it to the arbor. Elevating screw. The elevating screw has threads that can provide upward and downward movement to the knee and table by rotating it using a hand wheel. The next one, saddle. The saddle is mounted on the knee at the angle of 90° to the face of the column. It can be moved transversely along the guideways on the knee. Table. The table, mostly made of cast iron, rests on guideways in the saddle and provides support for the workpiece. And these workpiece placed on the work table is moved in either of the three directions. First one, transverse motion generated by the saddle's movement about the knee. And the second one, vertical motion produced by the vertical motion of the knee. The third one, a hand wheel affixed to the side of the elevating screw provides longitudinal motion. Overarm. Another name of these is overhanging arm. It is installed on the top of the column and functions as a support for the opposite end of the arbor and spindle, which extends beyond the column face. Arbor support. The arbor is a machine shaft that supports and drives the milling cutters. It is attached to the overhanging arm, clamping in any position. We can also view it as an extension of the spindle where milling cutters are placed and firmly secured. Working principle of milling machines. The cutting action is accomplished by feeding the workpiece against a rotating cutter. The workpiece is firmly secured to the table while the multi-tooth cutter positioned on the arbor rotates. The cutter rotates at the rapid rate while the material is fed. The workpiece can be fed vertically, longitudinally, or diagonally. The spindle speed, table feed, depth of cut, and direction of cutter rotation are the most important process factors. Now we'll discuss operations of milling machine. Upmilling operation. The upmilling is also known as conventional milling. In these, a cutter revolving in the opposite direction of the workpiece removes the metal in the form of tiny chips, as shown in the figure above. The chip thickness varies from minimum at the beginning and maximum at the end as the cutter advances. The primary drawbacks of the upmilling technique are the tendency of the cutting force to lift the work from the fixture and the poor surface finish. The second one, downmilling operation. A downmilling operation is also known as climb milling. In these operations, the cutter rotates in the same direction as the feed. The chip thickness varies from maximum at the beginning to minimum at the end. There is always less friction in climb milling, which produces less heat. Thin slots, lengthy cut, and sharpening of the pieces can be easily achieved in these operations. And the third one, plain milling operation. The most commonly used milling machine operation is plain milling. It is also referred to as slab milling. The workpiece is firmly mounted on the machine before this operation. After choosing the proper speed and feed, the machine is then turned on. This operation creates a smooth and horizontal surface that is parallel to the axis of rotation of the cutter as shown in the figure. And the fourth one, face milling operation. The most simple operation on the milling machine is face milling. This procedure is carried out with a face milling cutter that is rotated about an axis perpendicular to the work surface as shown in the figure. By turning the cross-fed screw of the table, the depth of the cut can be changed. This operation creates a flat surface with the cutter positioned on the stub arbor. Types of milling machines. Horizontal milling machine. These machines can hold and rotate the spindle horizontally to remove material from the surface of a fixed workpiece. Cutting tools for these machines are thicker and shorter. Vertical milling machine. This is a particular type of milling machine that can hold the spindle in a vertical configuration while rotating it to remove material from the surface of a stationary workpiece. Cutting tools for vertical milling machines are longer and thinner. Advantages of milling machine. The cutter having numerous cutting edges rotate at a high speed which results in a high rate of metal removal. It also follows that these machines produce better surface finishes. Milling machines are known for their higher accuracy compared to other machines. Disadvantages. It has a high rate of flank wear, high crater wear. Using a poor material cutter or machine with a loose arbor, vibration is generated. These can cause poor work on the workpiece. The chips formed during the machining can get clogged in the teeth of the cutter. Applications of milling machine. Milling machines are highly adaptable. Typically, they are used to manufacture flat surfaces. They are also capable of producing uneven surfaces. They can be used to bore, cut gears, create slots, and drill. Milling can be utilized to machine curved surfaces. Thank you for watching. Please do like the video.